After these 5 videos, now we can say least upper bound property is the one which we are missing in the rational number set. So we need new number system which fills those gaps so that least upper bound property satisfies, but we cannot leave the rational number set also. So we need new number system which is the superset of the rational number set and also includes a supremum of every subsets of it, that is the least upper bound property satisfies with it. So in this video we are going to see how can we define real number system. In fact, we did human beings worked with the real numbers and then we defined the real number systems. So for this video, our source is Essay on Theory of Numbers by Richard Dedekind, not the Walter Rudin. Walter Rudin just assume that we know this definition of real numbers and then he will continue with the cuts and all those things. So before that, I felt we should discuss what is meant by real number system so that we can understand why Rudin gave definition of cuts and why Rudin gave different definition of order for the real numbers, not just lesser than. Yes, those are the lesser than, but instead of saying x is less than y because x minus y is a negative number, instead of that he gave a different approach in his book. So that approach requires this extra knowledge, that's why I'm presenting this. We are going to define or going to learn the definition of real numbers. Let H be a set, not just simple set. This set should be proper subset of rational number and it should not be null set also. Now if a, b are rational numbers and a is less than b, again I'm telling that we assume that you know everything about rational number. That means you know what is meant by this less than symbol also. So a less than b and b belongs to L. That means b is an element in the L. Okay, then a should be also in the L. How? This diagram may help. See this q is there. Let's those dots cube let be those dotted lines represents q, and suppose b is there and b is a is less than b, then a belongs to Z. That means if a number given to you and you know that given number is in L, then every element lesser than that given element should be in the L. So but what is important is here, this is a proper subset. That means there are some numbers on the right side of its set which are not belongs to L. That is also very important. Not every rational numbers are there, so it looks like some part of the rational number and it's every lesser numbers are taken off, so it is like cutting. So even Rudin gives the same kind of definition. Let's hold those. So I believe what this statement telling you is the one I am intent to telling. That means a less than b is okay. A is also belongs to L. That is a very important thing here to understand what is meant by cut. So then L does not have a greatest element. This is also very important. That means this L should not have a greatest element in it. Okay, there should be no greatest element. It should be like a set. In fact, a set in the video number 2, set A is an example for it, where that is also a proper subset of Q, and all the rational numbers less whose square is less than 2 are all in the set A. Second property satisfies, and it also don't have the greatest element inside it. This is also a very uh, important important thing, or important uh, steps which are important properties which our L should have. Okay, so we call such kind of L as cut in the uh, Rudin book, but here we give definition of cut little bit different. I will tell you why both are same. Okay, let U be a set of all rational numbers which are not in the L. Okay, so this is a left out part. Then if U has a least element in it, that means what? There must be a rational number which is the least among the U. That means that rational number should be supremum of L. So L should have supremum. Instead of that, you can take U should have, if U has the least element in it, then we call the order pair L comma U as a rational number. And one extra thing is, this is from my side, you can think like that L comma U representing the least element in the U. So that rational number is uniquely defined by this L comma U. Okay, then if U has no least element in it, U has no least element in it, then we can call this order pair L comma U as an irrational number. Which is the example. Again, video number 2 is very important for this chapter. In that we have two sets A and B, set of all rational numbers whose square is less than 2, and a set of all rational numbers whose square is greater than 2. So both of the set have no least element and greatest element. That means of course our A here L is equals to A. Okay, so that A set don't have greatest element in it, fine, and that B is the Q minus A, right? So again that Q also not have, but there was a necessity of number. Similarly, every time this is going to happen. So instead of this video, for this definition, you please read the essays on theory of numbers. That will gives you a lot of clarity and a lot of questions also to think about. Okay, now union of set of all these order pairs where U has least element in it, and set of all order pairs where U has no least element in it. That means a set of all rational numbers and a set of all irrational numbers. We are unioning them. This is a formal definition, right? So this set is called set of real numbers, and each order pair is called real. But in the Dedekind book, real number. But in the Dedekind book, he called this order pair as cut, and he says that cut is the real number. That cut or the section is the real number, and thereon he explains a little bit more. I just wanted to tell what is meant by real numbers with lot of logical sense, not just some rude explanation, with lot of logical sense, as well as with the help of set theory. This is very important. This is the one which is going to be little more stronger definition of the real numbers. So from now on, our real numbers are the order pairs. Okay, order pairs of sets like L and U, and these order pairs are real numbers. So we define them like, we denote them alpha, beta, gamma, like that. So this definition of L is very important for our further topics. And If you are not understanding what I'm telling, please go and take the help of the video number 2. If that not helps, please take the help of the book corresponding part, and then also read this book, essays on theory of numbers, and refer other videos also. Because if you are not understanding this, uh, and all these drama or circus is a waste of time. So you have to understand this. And also, one disclaimer is, if you don't understand this, if you still want to learn real numbers, you can study the real numbers sets and real analysis also. This is not a mandatory thing to you should know the definition of the real numbers, because the whole humankind studied the real analysis and then defined the rational numbers, sorry, real numbers. So if you are not understanding at this time, you can skip this video and go for the further videos of the further chapters of this book. And when you have time, or when you feel I can understand, you can come and read, or you can go and uh, discover your own ideas in the book. So this is the definition of the real numbers, and this is not mandatory to move on. But if you are not understanding this one, and if you really feels you should understand, then go and watch all the videos and then come back and analysis with this video.